Our world is an enormous place, but so much of what affects each of us is too small to see with the naked eye. In the Department of Mechanical Engineering at Texas A&M University, Professor Deb Banerjee and his students are pushing the boundaries of small science.
I worked in the industry for a number of years after my graduate school, and when the offer came to start my own research program over here, that really appealed to me.
Texas A&M is a great school. It's got a lot of good things going for it.
Big university like this is able to take on very specific projects all across the board.
A&M is one of the largest universities in the United States, but Dr. Banerjee's work is some of the smallest in scale.
Nanotechnology are the things unseen that have big effect and big impact on the things that are seen.
I was fascinated by the technology to miniaturize devices and do things that a conventional device wouldn't be able to do.
Out of all the research in engineering and science that's going on, it has a lot of promise.
The reason that I'm into research is to have impact and effect on people's lives.
When I started at Texas A&M, 4 years back, I never envisioned the type of breakthroughs we have been able to achieve in our lab.
Dr. Banerjee's work has attracted plenty of attention, including interest from the Department of Defense.
While I was working in the industry, I got familiar with a government agency called DARPA, which is the Defense Advanced Research Project Agency.
And they had a challenge to do some so-called impossible task.
One of the grand challenges that they mentioned to me was the ability to grow carbon nanotubes for a variety of processes and for a variety of different conditions.
Nanotubes have the potential to open a whole new world of technological development, ranging from healthcare and electronics to green energy and even soldiers on the front line of battle.
Our idea was to try to grow them in a very specific location for application in electronics.
Definitely nanotubes have a great impact on making things smaller and more efficient.
Right now we know that the processors and CPUs are getting smaller and smaller, but eventually you're going to reach the limits of traditional methods.
Ironically, the smaller and smaller you try to build things, the bigger and bigger instruments you need.
To meet DARPA's impossible challenge, the researchers leaned heavily on the science of DPN nanolithography, or DPN.
Using the DPN technology, we were able to deposit materials exactly where we wanted it in a repeatable fashion.
It brings us one step closer to the next generation of computing processing.
The idea is very much like a nano quill pen, 10,000 times smaller than your hair. And the Nanoink software enables you to write any patterns that you want on the substrate.
So in effect, you have a very controlled way of delivering a chemical substance to a surface.
DARPA actually was pretty happy with the results that we got using the DPN technique.
Affordable, easy to use, and scalable, DPN brings sophisticated nanofabrication to the laboratory desktop.
We've been talking about molecular or atomic sciences for 50, 100 years, but only now are we being able to realize how we can change that and manipulate it.
I look at conventional devices and I see, oh wow, if I had used DPN here, and I would have been able to miniaturize this device to really incredible small scales, and I could have gotten a lot more functionality out of it.
DPN opens the door to easily building structures on a tiny scale that's never been possible before.
The promise of DPN is that it allows the user or the scientist to work with things at that scale.
If you think about it, if you look at the auto industry, before Ford came along, you had shops where they would make automobiles right from the scratch. And so what the DPN instrument enables you to do is to build a cottage industry where people make custom-made nano devices for each particular application or each particular customer.
There are enormous possibilities for using the DPN process, but Dr. Banerjee has even found a new way to use the machine's tiny parts.
The idea dawned on me that you could also use this same stylus to actually sense explosives.
Explosives give off a lot of particles in the air. We can use these, the DPN, the pens, to sense these particles.
And so in essence, it's like a personal safety device.
These explosive sensors could have a very big impact on soldiers' lives, on mass transit systems.
You can use it in airports, you could use it before a rock concert. You could also put it on an UAV or on a toy airplane, fly it around a city and sense, where if there is any particular concentration of, explosives.
Dr. Banerjee and his students at Texas A&M are working to grow the science of the small in fields like healthcare, defense, and energy. We may not always notice the tiny pieces of technology they develop, but will certainly feel their impact.
The commercial applications and the commercial potentials of using something like a DPN technology is pretty wide.
We're doing something that's never been done before. We're applying science, mechanical engineering to a brand new application.
So there's a broad band of different technologies that are being developed in our lab that is going to impact our ordinary human way of life in big ways.
Tomorrow we may be light years ahead of where we were the day before.
One question leads you to another, and you build devices or you build capabilities that you had never imagined or dreamed before.